Today we're going to look at section 6.7 for Algebra 2. Our learning target is to be able to add, subtract, multiply, and divide functions. So in our chart here, you'll notice that for addition of two functions, there's two ways we can write that. We can show it in parentheses like this, that just basically says we're taking f and g, they're being added together, and x is their variable. So I do want to be very specific. When you see this, it doesn't mean that we're multiplying by x. It simply means that we're taking f of x and we're adding g of x to it. So this is just indicating the variable that's being used. It's not indicating multiplication by x. So we can add, we can subtract, we can multiply, and we can divide functions. Notice that on this last one for division, we do have an extra restriction that says g of x cannot equal 0. Because remember, when fractions, our denominator cannot be 0. Okay? The domains for the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Okay, so we need values that work in both of the functions in order to combine them. All right, so our first example, we have f of x equaling x squared plus 2 and g of x equaling x minus 3. Find the following and state their domains. Typically, the domain is going to be all reals except in two situations. The first one is when we have a fraction. We talked about that. If you have a fraction, you have to make sure the denominator cannot equal 0. Okay? The second type of function that we have to worry about is when we have an even root, because the part inside, whatever is in here, can't be negative. Okay? So whatever's in there has to be greater than or equal to 0, 0 or something positive. All right, so with this first one, function f doesn't have any denominators and it doesn't have any even roots. It has an even power, but not an even root. So here my domain for f is going to be all reals. Looking at g, we have x minus 3. Again, there's no fractions and no even roots. So my domain for g is going to also be all reals. So now it's asking me to add them together. So f plus g simply means take function f and add to it function g. So we would combine any like terms, clean this up, get it in standard form. And so we could say our answer would be x squared plus an x. And then I can combine the 2 and the negative 3 and get negative 1. Okay? So x squared plus x minus 1. Now, with subtraction, you have to be a little extra careful because we are taking f minus g. Function f is x squared plus 2. We are then subtracting all of function g. And that's important because we have to distribute that negative sign. So we're going to have x squared plus 2. We're subtracting an x. And we're subtracting a negative 3, which means we're really adding 3. So now when we combine terms, f minus g would be x squared minus an x plus 5 if we combine the like terms. Now, in both of these cases, our domains were all reals for both f and g. There's nothing in my answer that indicates any kind of fraction or even root. So for both of these, the domain of f plus g is all reals, and the domain for f minus g is also all reals. All right, let's try a multiplication one. This time it says we are multiplying f and g together. So f times g. Our function f was x squared plus 2, and function g was x minus 3. So here we're going to have to do our FOILing. X squared times x would get us x cubed. Outsides, x squared times a negative 3 would be negative 3x squared. Insides, we get a positive 2x. And last term, 2 times negative 3 would be negative 6. And we don't have any like terms to combine. They're all separate pieces. So that's my final answer for f times g. Again, there's nothing, no domain restrictions, so the domain of f times g is also all reals. For the fourth question here, we're taking f and dividing by g. So f was x squared plus 2. We're dividing by x minus 3. Now for this particular one, we don't have anything that we can factor in the numerator and try to get to match that x minus 3 in the denominator. So there's really no simplifying that we can do on this one. However, when we look at our domain, we do have to consider that we have created a fraction now, so we have to worry about this denominator. X minus 3 cannot be 0. We can't have a 0 for our denominator. That means if we add 3 to both sides, x cannot equal a 3. So my domain, all reals except 3. So you can write that as reals, comma, x not equal to 3. All right, let's look at two new functions. This time f of x is 4x plus 7, and g of x is the square root of x plus x. For function f, my domain would be all reals. There's no even roots and there's no fractions. For g, though, we do have an even root here. We have a square root. And that piece that's underneath that square root can't be negative. So my domain for g would be that x has to be greater than or equal to 0. I can't let it be a negative number. And then when we go to add, subtract, multiply, and divide, we have to include those domain restrictions. All right, so our first one says take f plus g. So we have 4x plus 7. We're adding to it the function square root of x plus x. So all we can do here is combine like terms. So we could put these x's together. So we have f plus g would equal 5x plus the square root of x plus a 7. Now, once again, our domain for f plus g has to include that restriction that we had at the beginning. X has to be greater than or equal to 0. Okay, let's subtract. Again, we have to watch the subtraction of the whole function. So f minus g, we take function f, 4x plus 7. We subtract all of g. So we get 4x plus 7 minus the square root of x and minus an x when we distribute that. And then combining like terms, again, we have a couple x's here. This time 4x minus an x would give us 3x. We're subtracting a square root of x, and we are adding a 7. Again, the domain for this subtraction or difference of functions, x has to be greater than or equal to 0, since we have that square root that can't have a negative value inside. All right, our last example, we have function f is x squared minus 9. So again, no even roots and no fractions. So domain would be all reals. For g, our domain for g, x plus 3, there's no even roots and no denominators. So all reals. We're going to multiply these together. So f times g is x squared minus 9 times x plus 3. Again, foiling this out, first term, x squared times x gets us x cubed. Outside, we get a positive 3x squared. Inside, we get a negative 9x. And our last term, negative 9 times 3 would be negative 27. No like terms to combine. So f times g would be x cubed plus 3x squared minus 9x minus 27. No domain restrictions on this one. All right, and then for our division, taking those same functions, f divided by g. Our function f is x squared minus 9. Function g is x plus 3. Now we have some simplifying that we can do on this one, and we have a domain restriction. Because of this denominator, we cannot let it be equal to 0. So we're going to look at our domain for f divided by g. We have x plus 3 cannot be 0, which means x cannot be negative 3. So our domain would be all reals except negative 3. And again, you could just do this, reals, comma, x not equal to negative 3. All right, now going back to our expression here, we have x squared minus 9 divided by x plus 3. This is one where we actually can do some simplifying, because x squared minus 9 factors into a sum and difference, x plus 3 and x minus 3. And now you'll see that we have an x plus 3 both in the numerator and the denominator, so we would be able to reduce that quantity out and just have x minus 3. It has to be matching exactly the whole quantity, so I'm really taking this whole chunk x plus 3 and dividing out that whole chunk x plus 3. So final answer, f divided by g is just x minus 3 with the restriction that x cannot be a negative 3. So even though that part of my function dropped out, we had matching pieces here, we still have to include that domain restriction because it was there from the beginning. All right, we can't actually divide these two functions without restricting negative 3 from our domain. All right, so domains, look for both domain restrictions so we have, when we have a fraction, the denominator can't be 0. And if we have an even root, the radicand, which is that piece inside the root, has to be greater than or equal to 0. It cannot be negative. All right, let me know if you have any questions.